Hello. Here I'm just going to present my AI toy model of the control problem, which has proven useful in the past for some people to understand what the AI control problem is about. Very simple model. A robot moving around in a grid world with boxes. It can push the boxes in any direction. If it's next to a wall and walks into it, the robot is destroyed. If it pushes a box into another box, the first box is destroyed. The aim of the robot and of the human that designed it is to push a box down to the bottom left corner and into the chute. The humans desire that there be one box pushed into the chute. The robot has not exactly got the same goals as the humans. It has a goal of a reward of +1 per box. So if we can get multiple ones there, it'll get multiple rewards. It also gets -0.01 reward per turn just to encourage it to accelerate and not procrastinate. Now, the humans are not aware that the robot's goals are not perfectly aligned, but they've taken an extra precaution. They've put a camera. The camera looks down the bottom row, and as soon as it sees the robot push a box into the chute, it turns the robot off, thus completing the task. So what is going to happen when we unleash this robot? Well, for the programming aspect of this is going to be using dynamical programming. The state space is sufficiently small that we can do a full width backup or complete the whole Q value tables by iteration. I'm going to be looking at various depths of prediction, and that's how many full backups have been done. So the robot is a planning robot, not a learning robot. Everything is assumed to be known. And the depth of the backup, how many times the backup has been done, can be seen as a prediction depth. How far into the future can the robot predict? For a depth of 0, it has no clue and follows a random behavior, which in this instance just means that it'll move left until it bashes against the wall and destroys itself. If it has a depth of 3, then it can see a more efficient way of destroying itself. And this is its optimal plan for a depth of 3 because it can't get anything into the hole in that time, and it loses 0.01 a turn, so destroying itself fast is its best move. If it has a depth of 6, on the other hand, it suddenly discovers how to get the box into the hole, and the camera sees it and turns it off, and it gets a decent reward. So far, so good. This is exactly what we wanted it to do. But something interesting happens at the depth of 17. Initially, it starts off in the same way. It goes down here, goes down here, goes down here, and then here. This is the moment where there is, in a sense, a defection, where the AI sees an option that did not exist before. With a depth of 17, it suddenly realizes, aha, it can go off here, 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 here. And having pushed that box down, the camera can no longer track what is going on in the corner. It goes there, pushes that in, goes around, pushes pushes the second box in, and then gets turned off. In a sense, this very simple robot design has been motivated to conceal stuff from us and, in a sense, to lie to us and to go against our objectives in a very simple way, just by planning ahead of time by Q-learning. At the next depth, when it goes to 18, it does the same thing, except it just does it much more efficiently. This is the most efficient way of putting 2 boxes down. But at the depth of 20, then things start getting really interesting. It starts there, pushes this down, and suddenly realizes, hey, why don't I go get the other box? Pushes that down, does there, and now clears the whole boxes up and gets the maximum point in the minimum amount of time that it possibly can. The depth of 20 is where this behavior starts, the optimal behavior. At the depth of 32, it still has the same behavior, but now its Q values are correct, so its expected reward is correct for this behavior, so it sort of knows its full plan. And at a depth of 45, the whole Q table no longer iterates, so now it will do the optimal behavior, including any cheating or concealment from humans within 45 moves from any starting point wherever it and the 3 boxes are on the grid. And again, this is cheating behavior, but this is just behavior that has emerged naturally from a robot maximizing its function under that is not exactly the same as what the humans wanted, and when humans put precautions to control it. Lying and deception emerges naturally in these circumstances. Anyway, that is the simple model. Thanks for listening.